right. Good afternoon. Thank you very much for being here. I don't know how many of you were on my last session, but right now, I thank you. Unfortunately, I don't have a raffle on this session. Okay, so you have to be happy with just the content. Okay. But I'm going to talk right now about advanced pipelines for hypothesis-driven development. I'm Edson Yanaga. I'm a director of developer experience at Red Hat. My Twitter handle is at Yanaga. I also happen to be a Brazilian Japanese, a Java champion, a Microsoft MVP, and a TDC rockstar, which, at least for me, it's a very nice combination. Okay. And these were the raffle rules where I won't be able to have. I only brought one prize. And to give you a tip, this book discusses how can you break your old legacy monolithic relational database into smaller pieces, and then you distribute and integrate your data. And it's available for free on the Red Hat Developers book if you go to this URL. But if you go to my Twitter, the pinned tweet profile has a link to the book too. And now we're going to, well, advanced pipelines. If I had to say something about all of this DevOps discussion, microservices discussion, I'm assuming that all of you already know about continuous delivery. Creating a continuous delivery pipeline, it's not a problem anymore. You're able to just commit your code on a repository, and after some seconds or even minutes, you're able to have a new version running into production successfully with all of the tests, with all of the monitoring. Because this session is not a basic session, we're not going to discuss about this basic continuous delivery stuff. I'm assuming that continuous delivery is not a problem for you anymore, and you can get the next step regarding this continuous integration and continuous delivery pipeline. Because so far, every time we discussed about DevOps and microservices and continuous delivery, we are trying to solve the problem of bugs into production. So it was a safety thing. We wanted to be able to deploy our software into production safer. We didn't want to break things into production every time we had a new release. And we know, I used to be an independent consultant before joining Red Hat, and for more than 10 years I was trying to help people to accomplish that, even before we had this term DevOps. And I've heard a lot of different excuses, but the number one thing that I always did in any team, any company size, from small startups to big financial companies, healthcare industries and everything else, was that if you want to solve the bugs problem to production, the key metric that you need to attack is batch size. See, if you have big batch size, you have lots of changes between each one of your releases, you have a lot of bugs into production. Why is that? Because we as humans, we are very good in establishing correlation between things if we have the appropriate context in our minds. And when I say appropriate context, it means the appropriate amount of information for the right amount of time. So we're always trying to attack the batch size problem. And if you try to reduce your batch size in your continuous delivery pipeline, you're always improving your cycle time and your lead time too. Cycle time is the time between each one of your releases. And lead time is, the way I count it, is from idea to production. So if you're improving batch size, you're automatically improving other metrics too. It's very hard for you to improve the batch size and not improve the other ones. I would like to say that it's almost impossible, even though, you know, people sometimes make mistakes. And so the goal so far was to reduce risk. We want to play on the safe side. We want to be able to deploy things into production without bugs. And if we had a bug, we wanted to be able to fix that bug quickly into production. Okay? So in traditional pipelines, when I have version 1, when I have a version 2, when I have a version 3, I'm always assuming that the next version will be better, will be bigger, will be bolder, will have hopefully fewer bugs than the previous version. The next version is always better than the previous one. That's what a traditional pipeline do. So if I had to make an analogy about traditional pipelines, I'd like to say that traditional pipelines are like cooking in a buffet. So you have a restaurant, you have a buffet. You don't know who is the public that is coming to your restaurant today. So you have to cook everything for everybody. So you have to cook a lot of vegetables. You have to cook fish, chicken, and beef and pork and pasta because every user, every customer has a different taste. But then in the end, that particular day, you decided, well, you had a bus full of Indian people, and most of them were vegetarian. They went to your restaurant, they filled all the seats, and they all only eat the green things. So all the meat that you cooked, you just lost, and they're all just, so you have to hurry to the kitchen. Oh, we need to cook more vegetables, and that's how traditional pipelines work. You invest in the same amount of time and of course money on the features, even though you don't know how it's going to be used into production. That's why you have some scenarios where you're just cooking and baking that feature that you expect to be awesome into production, and then 6 months later you go visit the user and you realize that they don't even know that this feature exists. It happened to me a couple of times, and it's so frustrating. You just coded everything and nobody's using. And the product owner, the guy that was pressing you, putting pressure, oh, we need this feature because it's going to be awesome. And of course, we're always late. You have to deliver, and you put so much effort on that. It's not being used into production. And of course, we can blame the product owner. We can blame ourselves too. But the problem is that you can't know what is going to be successful into production before you deploy that thing into production. Okay? You don't know if the feature will have benefits to the business. You don't know if the way that you're implementing the feature is the best way for the business too. So these are only hypotheses that you have in your hand. But we are investing the same amount of time in all of the hypotheses, even though we know that some of them aren't going to be successful. Maybe some of them are simply bad ideas. And maybe some of the ideas that we considered bad are not being even tried because we don't have enough time for all of them. So this is a traditional pipeline. So the next step after traditional pipelines is what I say, a hypothesis-driven development. Because you have many different hypotheses, I think that if we implement this feature, I think that if we have this feature implement that in a different way, the users will have more benefits from our software. Our income will increase. We'll have more revenue. That's the hypothesis that we have. And when we have a hypothesis-driven development, the analogy that I make is that we're cooking in just small plates. So you have a restaurant. Whenever a customer arrives, you just cook some small plates for the customer, and you give like small tries for the customer. That, well, I like this one. I didn't like this one. No, not this one. Well, I only like these two different dishes. That's what I want to eat. And then you go to the kitchen and you just start cooking the ones that the customer liked. So you invested sometimes in the other dishes because you didn't know which one would succeed, but you only invested a few amount of your time doing that. So you just quickly discarded and you're just serving the user with the few dishes that he or she really wants to consume on that day. That's hypothesis-driven development. You don't know what they want to eat, so you just cook and invest a small amount of time on each one. You deliver, and the ones that are more successful, you just invest more time on that. Okay. And of course, when we're talking about hypothesis-driven development, there's a concept called A/B testing that most people are aware. But A/B testing, some people say, oh, A/B testing is just a matter of having like 2 separate deployments and splitting the traffic between these 2. This is a very, I could say it's an A/B deployment. It's not A/B testing, because if you have A/B testing, of course, somebody needs to be testing the hypothesis into production, and most people forget about that. Okay, so A/B testing means you need to test something. And if you want to test some hypothesis, you need to monitor behavior. And monitoring behavior is a very complicated subject. You need to learn some statistics. You need to know what to monitor. You need to know for how long. You need to create some baselines. One example that I give is that in a very famous ride-sharing application in Brazil, they just happened to be doing this A/B testing. They released a new version of their software on Monday. And suddenly, the number of ride shares just dropped very much compared to the last week. The developers were like, oh my God, what is happening? Did we screw something? Is the software not working to production? But then the ops guy said, well, wait. You're being too premature, because the baseline that we have from last week, last Monday was raining. So what happened? The number of ride shares increased a lot. Today is a sunny day. People don't need that much the ride-sharing vehicles to move from one place to the other. So if we just had a baseline from 1 week before, we would have made mistakes about the numbers that we get into production. So it's a complicated subject. You can read a lot about that, but I won't be able to cover today because I'm just showing you the techniques for hypothesis-driven development, and I won't have time to show you how you monitor properly these systems. But remember, you have to monitor these systems. And when I say traditional way of doing A/B testing is like, I have version 1.0, I have 2 different hypotheses. I don't know which implementation will be more successful into production. Maybe if I have this feature implement this way or the other way will be better. So I have version A, I have implementation A and implementation B, and in the end, after some monitoring into production, we just realized that version B is better. So branch B is the one going forward, and branch A in our source code is the one that is going to die. So you don't have a clear winner here. They're just hypotheses, and you just move the one that is getting better results into production. The first obvious way of implementing this kind of A/B testing is through feature branching. When I show you this picture, you automatically think, oh, I'm just going to Git and create 2 separate branches for development, and I'm going to commit each feature on a separate branch. That's how you thought about that. That's feature branching. But of course, it has some problems. But assuming that I have feature branching and I have like a very advanced deployment pipeline, every time I create a branch and I tag that with some special tag, it's going to create a new deployment to production. So I have a new branch, I have a new deployment into production. And I need a way to be able to route my request between feature A and feature B. Traditional routers can do a dumb version of routing. And when I say dumb, is that if you're using an infrastructure router, all you can do is say, I want like 50% of my request going here and 50% going there. Or maybe 10%. You can do a dumb canary, 5%, 10%, and everything else. But if you want really fine-grained hypothesis-driven developments, maybe you already profiled your users. I'm testing this feature, but this feature is targeted at this specific population. I only want to target people like female users from the Czech Republic that are iPhone users. So I want to test the feature because that's my specific target. I want to improve my sales to that specific audience. Or maybe that's the audience that I'm having bad results. I'm having a lot of bugs into production, and after some analysis, I just realized, well, most of the bugs that I have into production are from this specific population. I don't want to risk deploying a new feature to all of my user base. I only want to test on that population that is giving me problems. So I need to provide some smart routing mechanism. So basically, a smart router is something that you put on front of your deployments, and you add some business logic on your smart router to be able to route your request between one and the other. So, and how can you do that? If I just go here, let me try to mirror it. Okay, here I have on this terminal, I have a Zoo implementation running here. Zoo from Netflix is probably the most popular smart router implementation available. If you dig into the source code of Zoo, it's very simple. You might be thinking, well, anybody could have done that. Well, but they did first. And Zoo uses Groovy scripts, so it basically, since it's a dynamic language, it can reload itself dynamically every time it's running into production. And the way that Netflix uses that, they have a Cassandra distributed file system, and they have a Git repository. So every time somebody commits a change to the Git repository of the routing rules, it gets distributed by Cassandra. And Zoo, by default, it pulls the folder every 5 seconds. So if you have a change on the files, it just reloads the files automatically, and you have your routes changed in production. That's the way that Netflix does. Not everybody is Netflix. But luckily, you have some different implementations, like if you're using like Kubernetes or OpenShift for something like that. You could be tying your files to a Git repository. So every time you have a commit, you just redeploy the things, which for most enterprises, I think it's even more safe than doing the way that Netflix does, because you need a lot of people to maintain that thing. But it really depends on your use case. I'm just saying that if you're using Zoo, you need a way to be able to reload dynamically the files that you're implementing. So I have zoo running here. So let me show you the source code that I have. Let's open presentation mode. So if I just end here, it's Groovy code, but it's most of the time it's Java compatible. So if I just get here, you see that I just implemented a standard round-robin routing. I'm saying that, well, half of the time to go to the blue pipeline, and half of the time we'll go to the green pipeline. Let me open here my console. So I deployed some instances here in my OpenShift instance. So I'm using zoo to be able to, if I go to my zoo router and I hit refresh, of course it's always going to blue, which is a bug. Okay. Let me check if things are working. Blue, blue, and green. Okay, there. And now I just go to my, I remember. Now if I go to my pipeline, here, first I have to show you something. If you want to create like dumb routing, I could just go here to OpenShift and go application, routes. I want to create a route. I want to say I want to create a blue-green. Blue-green. And I want to alternate, split the traffic between blue and green and 50-50. If I just do that, I can open this blue-green deployment. This pipeline, if I hit refresh, of course it doesn't reload. But if I open my Chrome here, it doesn't reload either because the OpenShift router is sticky by default. So if I open another browser, if I'm lucky, it will be green. Oops. Green. Okay. Oh, lots of plugins, sorry. And it's green. So you have, it's sticky, so I keep reloading here. The OpenShift router is always sticky. But if I now hit my zoo endpoint, if I want to provide some smart routing, I can say here, green. It doesn't reload because I need to open the Chrome Spectre for it to make always a fresh request. So every time you see, it's round robin. Let's try to get like an Android phone, get round robin. But if I want to add some business logic, I just go here to my zoo implementation. And I decided here, well, I want to get some headers, and I want that all of the iPhone users should go to the purple pipeline. So if I get and open my browser, blue, green, and if I say now it's an iPhone 10, and I hit refresh, it's going to the purple. So Zoo, it's a very simple implementation. It's very easy for you to change the root rules here inside Zoo. Of course, I use a user agent header, which some infrastructure routers can do for me. But if I'm really smart, I would have already profiled the user. I know who's logged in my application. I'm just going to get, well, this particular user is from the population that I want to test. I'm going to route the user to the new deployment. Okay? So Zoo is very nice because it allows you to have any kind of business logic inside your routing algorithm. So you can like have query users, you can query like users from a specific population, from a specific region. So it's very flexible, very nice. That's why some people like Netflix use Zoo. Okay. But of course, you have to be careful with feature branches. And the problem with feature branches is that in traditional pipelines, we always try to reduce the batch size to reduce risk. If you're using feature branching, you have the possibility of increasing your batch size too much up to the point of making big mistakes. What's the problem with that? Well, suppose that you have trunk or master, depending on how you name that, and you're developing two different feature branches, feature branch A and feature branch B, and suppose they're not even related to the same feature. They're a completely separate feature, maybe implemented by different teams inside your company, and you decided, well, feature branch A, well, you're doing all of the best practices for continuous delivery. Of course, your feature branch, you're continuously integrating with the trunk. Somebody commits on the trunk, you pull the changes and you run all the tests again. You're doing everything right. But the problem is that team B is already developing another feature in another branch, and they're modifying the code a lot. And they spent like 2 weeks developing this new feature branch. And when the business guy said, oh, feature branch B is okay, is doing great results in production, you can merge that to trunk. And then what happened? The commits from 2 weeks, which could be thousands, are just merged in a single command to the trunk. And then the guys developing feature branch A, they just decide, oh my God, why are we pulling so many changes at once? That's a big batch size. And they will have a big conflict. And in all of the teams that I visited, when they had this kind of feature branching, that they had this huge conflict, in the end, they just decided it was too complicated to try to merge anything. And usually the project lead just says, well, guys, just save the files that are important to the project, copy, paste them somewhere else, just discard everything and copy it over. And you can see that every time somebody suggests you to copy-paste, can't be a good thing. But that's what happens with feature branches. That's what happens when you have a big batch size. So if you decide to use the approach of feature branching in your code, you have to make sure that these feature branches will be very short-lived. Okay? Like, how short is short-lived? Well, it depends on your company. For some startups, like 1 day is a very big branch. For some banks, 1 week is a short-lived branch. It really depends on your business use case. I visit some startups. Oh, God. And I paid for the plugin. Some startups where they're committing like a lot of time and they're deploying like maybe 20 to 50 times per day. Maybe 1 day can be a lot. So you really should be evaluating your business use case to tell how long a feature branch can live. Another approach, if you don't want to use feature branching, you might be using feature toggles. And if you want to know how can you implement feature toggles, you might be thinking that feature toggles are a very nice way of saying that you have a distributed if in your code. Okay? If enabled, do something else, do something else. And the two most popular implementations in the Java world are FF4J and ToGoZ. I was able to use FF4J into production a couple of years ago, and ToGoZ has developed a lot in the past few years. So I've talked to some teams worldwide, and they were successfully using ToGoZ. So I might say that these days is a matter of taste. So if you want to configure your things using a repository, or if you want better Spring integration, maybe you want to use FF4J. If you want your feature toggles to be like 100% Java code, maybe you want to use ToGoZ. But the basic premise of any feature toggle framework is that you want to separate your releases from deployments. Because you might be able to be deploying many different versions into production before even releasing a new feature. And the most popular use case on the internet that you can read about is for the Facebook Messenger application, because Facebook, they didn't know if the infrastructure would be able to handle the amount of messages that Facebook Messenger would be sending to their backends. So what they did, they just deployed the feature into production, but they didn't release to the users. So they had some JavaScript running on your Facebook page. Every time you went to the Facebook page, you have some JavaScript sending some messages to your close friends, being hidden from production. So they could see, oh, backend is not performing well enough. They were able to change the infrastructure until they were confident that the backend would handle all the messages that went into production. And when they decided, well, I think everything is okay, they just flipped the switch. They turned the flip to on, and then suddenly the Facebook Messenger icon appeared on the website. And everybody was able to send like cute cat pictures to your friends, to your grandmother. So that's how release separate from deployment works. And I want to show you how can I use that. Using, in this case, let me exit my zoo. I'm going to close it. I'm also going to stop my zoo implementation. Okay. I don't think I'll have time to show both implementations, but I have this source code available on GitHub. So if you get here, I have just a plain FF4J implementation. So let me try to run it. FF4J loads their configuration by default from an XML file. So if I want to see how they are defined, Here I'm saying that I have 2 feature toggles. One of them is hello, the other is new recommendation engine. And how do you store them? Here I'm using an in-memory store. It means that every time I restart my application, I lose all the state of the feature toggles. But of course, in production, you would be saving that state on a database, or maybe in a key value store like Redis into production, or maybe using Cassandra or other backends that are available to the FF4J implementation. Okay? Or if you don't like them, you can implement, it's just an interface, you can implement where do you get the feature toggles, whatever you like that. So if I want to open here localhost 8080, and if I want to say hello, it's returning hello. But if I want to go to the FF4J console, F4J, you can see that it provides me some features. And I can, if I flip the switch to off, if I go to hello again, it's going to return me olá, which is hello in Portuguese, which is my native language. So I have here other endpoints for recommendation. If I have a recommendation, the recommendation, now I live in North Carolina, and the typical dishes there are pulled pork, hush puppies, and beer, which you might maybe agree on beer, which could be a great thing. So if I could just create a new implementation of that into production, I would say that my recommendation controller works like this. Okay. And I wanted to do some live coding, but I'm short on time. So if you want to have, traditionally, I have an interface recommendation engine. And I say, well, I have 2 different implementations. If I get the default recommendation engine, it's just returning me these strings. Because traditional A/B testing, people just show, well, I want to change the color of the button of the interface, which is A/B testing you do on the client side. But if I want to change implementations on the back end, that's where feature toggles really shine for us back-end developers. So I want to switch implementations. So I have 2 different beans in my application here. So I have 2 different beans, one default recommendation engine and one improved recommendation engine. Both implement the same interface. So if you ever use Spring, you know that it's going to be a conflict. I just have to mark one of them as primary. So whenever I have a conflict, he's going to pick this one first. Okay, and if I want to use that, I just go to recommendation controller and just say that at FF4J feature, and I give the name of the feature. So FF4J is going to switch dynamically, it's going to create a proxy, and it's going to flip dynamically the implementation depending on the state of the feature toggle. Okay? So if I do that, you see the implementation. So I have pulled pork, hush puppies, and beer. If I go here to my implementation, let's go to the features. And I want to switch on the new improved recommendation engine. And of course, since here we are in Czech Republic, the recommendation is beer, 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 because that's what you eat every day, right? And that's a better recommendation engine. Okay, and that's what I wanted to show for FF4J. And now we're talking, well, the problems about, I talked about the problems about feature branching. I need to talk a bit about the problems of feature toggles. The problem with feature toggles is that sometimes you have too much feature toggles. Yeah, okay. And when it's one feature toggle, well, let's turn it on and monitor the production. Let's turn it off and monitor production. Let's have 2 feature toggles. Maybe they're testing independent branches of your source code. Then you can have 2. But I visit some teams, and some teams had like more than 100 feature toggles went into production. And what happened with that is that, well, team A was performing some testing, and they, well, turn it on. We're having some metrics. Turn it off. We're having the same thing. Turn it on again. Oh, now it's different. What has happened? They decided that the metrics that they were having from monitoring production didn't mean anything at all, because the state of the feature toggles in production was never consistent. You never had the same state. You could never have a baseline. You don't know if it's performing better or worse. So in at least 2 of the companies that I visited that were using feature toggles, and when they had like too many feature toggles, like more than 100, and of course, when you have that much, you have like many different teams testing. Each one of them is testing their own feature toggles. They decided their solution was, at least in these 2 different companies, was to create a feature toggle committee. So they had one person from each team. They created a committee, and this committee would meet weekly and decide which feature toggles would be being tested on that week. So, I'm testing feature toggle A. What does it do? Oh, it does this. Oh, it conflicts with mine. It means that if you're testing this feature toggle, I can test mine. So they had to sit and talk about what was happening to be able to have like meaningful metrics into production. And I don't know if any of you have better suggestion for that, but that's the solution that I've been able to find in different teams worldwide. You need somebody to be talking to the others to know which feature toggles are being applied into production. Okay? And we're talking about feature branching and feature toggling. And now I'll give you a very specific case of hypothesis-driven development. Maybe this particular case can be applied only to backend systems and more specific for performance problems. Or maybe you have a new algorithm, you want to test that in production, you don't know if it's going to perform fast enough, you don't even know if your algorithm is going to give the right results into production. And you need to compare these results with the code that you have running right now in production. So you need to duplicate the results. So with service, I applied this approach in the past only once. And to tell you, it was very hard to create what I'm calling right now mirroring, which is the ability to have, I'm having production requests going to a backend, but I want to mirror the requests. I want them to be processed at the same time for two different backends. But the production requests are going to be replied by the production backend, and I only want to test if the results are right or if the performance is right on the separate backends. In the past, it used to take a lot of time to be able to produce these environments. Luckily, 2018, we have tools that makes this process much easier, like service meshes. And I'm talking particularly about Istio, which is the tool that I'm going to demo for you right now. So just to give you a very quick introduction about Istio, Istio has three different, you have a control plane, you have pilot, which is responsible for the rule propagation and for most of the routing. Mixer, anything statistics related, I want to rate limit that endpoint. I want to have rate limiting. I want to limit some number of requests or this kind of things is from Mixer. And Istio, which is now called Citadel, is regards like mutual TLS and authentication. So these are the three components. The components that I'm going to show right now, like for mirroring, are related to Pilot. And how Istio works is that it's a very smart idea. If you ever learn a bit about Kubernetes, you learn that Kubernetes orchestrates pods instead of containers. And what is a pod? A pod is a collection of one or more containers. And I never knew, well, why the hell did they choose pods instead of just using containers? Well, all of the containers inside the same pod, they have the same life cycle. And at least for me, I could never find a good reason for using pods instead of containers until Istio was created. How does Istio work? Every time you have a container, which is your application, running into a pod, Istio adds another container into the same pod. This other container, which by default right now is Envoy, which is a very lightweight sidecar implementation, you have a sidecar container running with your application container. And this sidecar container proxies all of the traffic that is incoming and outgoing from your container. So you can do very nice things inside your sidecar, for example, mirroring. You can do authentication, you can do tracing, you can do monitoring, you can change the exit rules, you can deny some requests to outside using your sidecar container. So it's a very smart implementation. I strongly recommend you to read a bit further because that's the way distributed systems are being built these days with Istio. And most of the Istio can be deployed in different implementations, but I have to confess to you that right now, Kubernetes has won the container orchestration platform wars. So most of the documentation, the works, the articles that you'll be able to read into the internet, we'll be talking about Istio on top of Kubernetes. Okay. So let's go for the demo. So how is it going to work? I have here on my Kubernetes deployments, Kubernetes OpenShift. I have 3 different microservices, customer preference recommendation. Each one, customer is calling preference, preference is calling recommendation. And if I go here to my terminal, I just want to increase. And you see that I'm sending some curl requests to my backend. And since I'm not using Istio for anything, I have two versions of recommendation on my backend, version 1 and version 2. So I'm getting the default Kubernetes behavior, which is a round robin. One request goes to one, another request goes to the other. It's a 50-50% round robin load balancing. But what if, and if I get here my logs, you can see that, I think I have to rerun. If you get the logs, you see that one request goes to version 1, another request goes to version 2. So these are moving one. I have log from one, then I have the log from another one. Okay? And I have to click for them to refresh. So what I want to apply right now is, if I'm still getting the requests, it takes some seconds to get a new fresh request. So I get some buffering here. But I want to apply mirroring. So if you go to this URL, bit.ly/istio-tutorial, which I believe to be the most complete Istio documentation available on internet. It's not because I did that, but I think it's really great. Okay, so if you want to have a documentation about Istio, and then on Istio, we have some great examples, and I'm going to show you I can create these two rules on Istio, and we will allow you to mirror the traffic from recommendation. Now I want all of the requests, instead of going to recommendation version 1 and version 2, I want all of the production requests to go to version 1, and I want the request to version 2 to be mirrored. But the production replies will come from version 1, and the version 2 will be fire and forget. Okay? So if I just decide to apply, oops, wrong folder. If I just decide to apply these rules, I created these rules. If you get my log from here, you see that I don't have requests to version 2 anymore. All of the requests are coming from version 1. Okay? And if I get to check my logs, you see that every time that I have a request to version 1, I also have a request going to version 2. And they're going at the same time. So I might have different implementations running into production. And the next question is, how do I know if the version 2 is running properly? Okay, because if I have a simple service, REST endpoint, for example, I could check just the replies. How do I do that? Of course, some people are solving this problem for us. So let me get back to my presentation. So one of the possible tools that you can use to check the reply from the production request is using Diffie. Diffie is an open source tool that was released by Twitter, because that's the tool that they're using to production to check the requests. They mirror the traffic to a separate deployment, and they just get Diffie, and Diffie compares the production that the reply that is coming from production and the reply that is coming from the mirror. So you can compare them side by side to see what is changing. You can tag some areas of your reply to say, well, this is a timestamp. It will always be different from both requests. So I only want to have the comparison of this segment of my reply. That's a very nice tool, just in case you're interested. Another question is that, well, okay, I don't want to check just the reply. Maybe the reply could be the same, but I want to know how my data is being stored into production. So in my book, I solved some of the problems that you have when you're trying to run different releases of your version into production, particularly regarding the database schema. So I have different database schemas running into production. How can I handle that in my code? And chapter 3 of my book deals with that. But if you have like more advanced problems, I think I'm missing a slide here. What can you do? You can add a virtualization layer on top of that. So one of the things that we try is that I have like production database, I have a mirror database. One of the things that I did myself, but it has been like 5 years, when we created a mirror setup, requests went to both backends. But for me, I had to have to ask the DBA to perform a backup of the production database, restore that into a separate instance, and point the mirrored instance to the new one. And I kept it running. But since it took so long for us to create this mirror replica of my database, I had to run the mirror for so long. But the problem is that more time you run the mirror, the more time the data gets different. So it's very hard for you in the end of the day to know if the data in your mirror is giving you the right results or not. So what did we do with data revitalization? We used TEID, which is an open source project, to mirror the data. So we created another database which has the same schema of the production database. We added a virtualization layer on top of the test database, of the mirror database. And what happened? Whenever I had a request to the mirrored service, it would merge the results from the mirror database and the production database and give me the results. In the end of the day, what did I have on the mirror database, which was empty in the beginning of the day? I only had the data that was different from the production database. So it was very easy for us to test if our algorithm was wrong or right. Because we were able to go to our database, just issue some select statements. I would only see what was different from production. So it was very helpful for us to be using that. Another problem with mirroring is that sometimes if I only have one backend service, it's very easy to provide mirroring. But what if I have like this microservice calls many other microservices, and of course I don't want this request to be duplicated into production. I need to mirror all of the dependencies too. It can become a dependency hell. So the answer for that, you can use, for example, service virtualization, which is a very nice name for mocking external services from your mirrored engine. And I thought that service virtualization is a very dumb name for mocking. But who created that? Then I realized that, well, service virtualization is a very old name. It comes from the 90s, from the SOA architecture. So they just didn't create a new one. They just reused the concept that was already lying around. Okay? And we have a service virtualization chapter available on the Istio tutorial on the internet, just in case you want to learn more about that. Okay? And that's the discussion that I wanted to have with you today. All of this content will be available at developers.redhat.com. If you go to bit.ly/istio-tutorial, you can find the Istio tutorial for you to try. And if you want to reach out to me, I'm available at my Twitter at Yanaga. Or my email is available to you too, yanaga@redhat.com. But I have to tell you my SLA on Twitter is better. Sometimes email can have a bad SLA, like for weeks. So that's what I want to show, and I might have some time for questions. Thank you very much. Any questions?
So when you talk about Zool, where do you put it? Because if you put it in the front, right, then maybe you can route to a target service. But then if the target service is also used by other services, then do you also put Zool like in front of the target service, so each service basically has a router in front of it? Or would you rather use like Envoy proxy for?
Mm-hmm. Yeah, the way that Netflix uses into production, they have multiple Zool instances running. So every team is free to test their own feature branches. So sometimes you can have a front-facing Zool and calling these two different instances. But this service called multiple other microservices. And each one of these microservices might have its own Zool gateway. So from a network architecture point of view, each endpoint is a black box. And each black box might have its own Zool instance running there. Okay? You're welcome. Any other questions? I might have explained it very well or very badly. Right? That's usually the two hypotheses. You need to see hypothesis review on the bottom. I'm testing in production right now. No? If you don't have any further questions, then Prague and GeeCON, I'd like to thank the organizers. Thank you very much for having me. Yeah.